Good morning. I'm Dr. Jyoti Kumar. Today we'll discuss about the topic thread in operating system. We have a process. If we have single process and we have a multi-threaded process, here I have represented a single-threaded process and a multi-threaded process. The process that have a single thread of control, we can term it as a heavyweight process. The process that have a multiple thread of a control, then each thread we can term it as lightweight process. On the multi-thread process model, we can represent as a many-to-one, one-to-one, and a many-to-many process. In many-to-one, we have a number of user threads, and we have a single kernel thread. Many user-level threads map to a single kernel-level thread. One thread blocking causes all to block. Multiple threads may not run in parallel on a multi-core system because only one may be in a kernel at a time. So one thread is going to utilize a kernel thread. Then, so this is a blocking system. Then all the other threads will not going to execute since it needs a kernel thread for the process. And a few system currently uses this model. Example: Solaris Green Thread and GNU Portable Thread. Next one-to-one model. Here, each user level thread maps to a kernel thread. Creating a user level threads create a kernel level thread. So each thread is going to map with a single kernel thread. Similarly, for n number of threads is going to map with its own kernel thread. More concurrency it will happen than what we saw in many-to-one model. So this thread is going to execute with this kernel, and similarly, this will not affect a single blocking system will not affect the other process or other threads on its execution, because each thread has its own kernel thread. The number of threads per process sometimes restricted due to overhead. Example: Windows, Linux, Solaris 9 and later version. Coming to many-to-many model, we have a number of threads, and we have a number of kernel threads, user threads, and we have number of kernel threads. It assumes to be a multiplexing model where we have n number of user threads, and which is going to have a multiplexing, and we have a number of kernel threads which may be equal or lesser than that of the number of user thread. Allowing many user level threads to be mapped to many kernel level threads allow the operating system to create a sufficient number of kernel threads. And then Solaris, we have version 9 in this model, and Windows with thread fiber pack edge is an example for the many-to-many model. Thank you.